Hello and welcome to this video on how carbon creates four very different and distinct compounds despite all being based on the same carbon molecules. For this to happen, each must be unique in some way. Carbon is the most basic form of what we are talking about, the element or atom, the single smallest building blocks of our universe. It is the 12th element on the periodic table. Carbon also needs 4 electrons to fill its outer shell. That means it can combine with up to 4 other atoms. This allows the carbon to create different allotropes or connections and arrangements of its molecular structure. Carbon by itself is unstable, but carbon is readily stabilized in multi-atom structures with diverse molecular configurations. Carbon needs to be stabilized as it cannot exist by itself. This is why carbon is the backbone of any organic molecule. Charcoal is perhaps the most crude and simple form of carbon as an aggregate. The process of generating charcoal generally involves removing as much of the other non-carbon material as possible by heating away volatile compounds. This largely leaves only carbon behind. The heating process is relatively low temperature compared to other processes, somewhere in the range of 800 to 900 degrees Celsius, enough to heat off water vapor, volatile compounds, but leave the carbon present. By doing so, it is a broad aggregate of carbon. There are, however, some inclusions and contaminants. This creates a crude form of carbon. It burns and is easy to make, which is why it is a historically favoured fuel for metalworking. There is about 68 to 82% carbon in charcoal. The lowest percentage leads to the creation of allotropes. These are from reactions with the inclusions. Diamonds are like charcoal, but pure. Clear or white diamonds are entirely pure with effectively no contaminants. There is only carbon present. Coloured diamonds, such as yellow and pink diamonds, have small amounts of nitrogen present, and this alters the structure of the crystalline form. That change in structure leads to the observed change in colour. Assuming for now we are discussing a normal, white or clear diamond, it is generated in a hot environment with high pressure, 900 to 1300 degrees Celsius, and a pressure of 45 to 60 kilobars. This is tens of thousands of times the level of our day-to-day atmospheric pressure. The extreme heat and pressure under which carbon is generated leads to the formation of a much more regular structure at the atomic level. It is a tetrahedron made of 18 carbons. These combine and build up to make a diamond. Each corner of a diamond on the inside or intersection is made of 2 carbons. This creates a series of repeating structures that are relatively regular and consistent. The more consistent the temperature has been and the pressure, the more consistent the structure of the diamond is. This is one reason why diamonds can be everything from cracked and warped, with many inclusions, cavities and other deformities, through to extremely regular and highly prized specimens. Graphene is perhaps the most complicated of the carbon allotropes we'll discuss in this video, and that is because it is created synthetically. The reason for this is the very regular structure of graphene. It is a series of hexagons. These are very hard to make in nature, if not impossible for practical reasons. What occurs instead is they can be created in an artificial environment. Graphene is a 2-dimensional sheet. It only occurs as a ring of carbons. That ring is in fact a hexagon lattice. By creating a hexagon, it is strong and becomes able to withstand forces on a given plane. The layers of the lattice can be stacked for greater strength. The ability to deposit a single layer of carbon is almost impossible in nature due to variations in temperature and pressure. It is really only possible in the artificial environment of a laboratory. Graphene is, in a manner of speaking, something like chalk or slate, strong on one plane but weak on the other. This is the reason there is a sheet of graphene. but it can also become several layers. And that is from the way the joints intersect. It creates points where electrons can be part of a joint between graphene layers. This is not everywhere, but only in a limited number of locations, where multiple different features come together. As you can see, carbon begins as a single basic molecule. When it begins to aggregate in a rough and jumbled manner with no consistency or order to it, we wind up with something like charcoal. As you get to progressively more ordered and structured, which requires more energy be put into it, you get diamonds. And at the most extreme end is graphene. That is why there exists several layers of complexity to carbon. We know some of these in daily life, such as charcoal and diamonds. In fact, even in the future, graphene may become commonplace, and yet even more complex and ordered structures made from carbon will take over the role of being the unusual or unknown. This is perhaps the strength of carbon as the backbone for many structures. The fact that it can be used to join to 4 other structures in turn. It can act as a bridge or the basis for an entire molecule. It can also bond to itself and create something very simple, but very compelling, like diamonds. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you might have below.